we'll start with this stray light analysis. So initially, the part 2 we had designed one infrared objective that works in your LWR range from 18 to 14 micron. And using 4 aspheric lenses, we had optimized it to a diffraction-limited performance in your wavefront quality, image quality, and spot diagram. The F number was 0.63. So now we move towards the stray light part. So once your design is completed in Zemax, then there is something called as ghost focus imaging, where you can identify the critical surfaces. This is something that happens in sequential mode. Then the next part would be conversion of your design into a non-sequential, so that it can incorporate for the stray light analysis. So it will be sequential to non-sequential conversion, parallelly. Now if you're using Zemax only, then you'll need an external CAD software where you will be exporting your CAD, your optical design, and create your opto-mechanical. Then, there will be some base stray light analysis as to how this geometry is behaving in that random stray light behavior. Then, we'll apply coatings, your anti-reflection analyze coatings. Then, do the path studies to see where the stray light is majorly coming from. And later on for CAD modification, we can do to and fro between the softwares. So, this would be the typical workflow. And this is how your stray light analysis image might look like when you're doing the analysis in Zemax, coming to the advanced stray light part in Speos. So again, the design starts with Zemax. You export the design from Zemax to Speos. So there is a direct option in Zemax to export the design to Speos. So it creates a ODX file. And that entire design, with all the material specification, whatever the coatings or a modification that you have done in Zemax, will be translated as it is to Speos. Speos is a CAD agnostics platform. So over there you can do the opto-mechanical design. Then you can define the sources, environments, and complex CAD, and perform advanced stray light analysis like a sensor validation, dot sequential path analysis, as well as the baffles optimization. So, just to completely understand this whole workflow, the Zemax and Speos, more or less they are contributing to some point and all. If you just give a comparison of both, when it comes to Zemax, you can do this exact workflow. But whereas you have few advantages, like it's a single tool and it's all about optics and you'll have quick insights then and there itself. But coming to limitations, it slows down for complex CAD. The system we took is very simple. It could be done in a simple way. But when complex EH system comes into picture, like for example, designing a large telescopes and off-axis systems, then the complex CAD comes into picture, and it takes a lot of time for Zemax to handle. And there is a tedious task for external CAD modifications. Even though you find the path analysis that whatever the surface contributing to sensor, it's somewhat tedious to modify it. You have to perform to and fro between CAD software to Zemax and the material environment and CAD environment. And also the background, you create environment sources and visualizing the sensor imaging. So, there are few things that Zemax stops. And also you can. There is no GPU or HPC capability to, perform the simulation faster. And coming to Narcissus analysis, it's like a completely limited capability, like using so many assumptions and all. But when you come to Speos, the same workflow that we have discussed previously, so it can extend to opto-mechanical CAD's environment and number of external sources. It's not just sun anymore. You can have different thermal radiation bodies or any other interior or exterior lights. You can use all those in Speos. And it's a complete CAD agnostic tool. So you can modify the important CAD there itself and visualize the SNL, and also you can visualize the imaging performance, how the images are taken for a created scene. You can perform DRI analysis and you can create the sun position using latitude, longitudes, and city and country locations. And you also can give different materials and different finishes of the body, like rough surface, smooth surface, and understand the ray tracing accordingly. So when it comes to smaller optics, the Speos is completely a system level. so there is a limitation for designing the optical system, smaller optical systems in SPIOs. But once your optics design is done, so you can say SPIOs can take you to the system level and for a fully automated and system level simulation analysis.